All right, so welcome back to COMP335. In this unit, we'll talk a little bit about motivation and about learning theory, theories behind what motivates students, and theories behind how learning happens. I basically want to give you vocabulary, things that you can use in your essay as well. Basically terms that someone who takes pedagogy seriously should just know, or at least be able to recognize. Maybe you don't need a lot of detail about these at that stage, but you should know that these exist and maybe be able to look it up. And so I'll basically fire a few different things at you. They're all relevant for designing your lessons, I think, but they're more in the background. You will see what this means in a second. And I'll sprinkle in between those kind of theoretical topics some best practices that people have applied, how you can put that into practice in teaching. I want to start with a little warning, and that was your pre-session task. We can go through your results in a second. But the story behind these learning types, so just to recap, your task was to assess yourself in this VARC learning styles framework. So visual, auditory, read writing, and kinesthetic. And there was an observation by some education researcher that kids use different representations of material at different efficiency. And so he came up with this theory that maybe every person has a dominant way how they like their material to be presented, and then they're more effective. It just turns out that this doesn't seem to be true. There are different ways to represent things, and sometimes one is more efficient, sometimes another is more efficient. But separating your learners by different styles just doesn't seem to help. And if anything, it might even hurt if you distribute your attention. So it's a nice example that demonstrates that you have to do empirical research. If you come up with such a theory, you need to test it in a proper setting. Something that we'll come back a bit in the fourth unit, how to do that, or at least how to read about these. Otherwise, you can just claim random things, and we'll never know if they're really effective or if they just sound plausible. Can I have a quick hands without a long Slido question? Was this known to you, or was this new? Who knew about the styles, learning styles, and that they're kind of bogus? So the rest didn't know it? Have you heard about learning styles before? Yeah, good. So I hope this worked as a little revelation for you then. There's still some valuable insights in this observation. I mean, these four categories, I think they're a useful way to categorize different representation for material. And representing things differently actually helps. So there's supporting research that shows if you present things in multiple ways, that helps everybody. It's just the part that's not true is there's visual learners and they prefer always the visual things and we learn better with visual representations. That seems not true. But combining different representations is universally good if it's used in a sensible way. And it's still somewhat interesting that maybe people have a certain preference for different representations, but it's probably quite dependent on the task. So I should probably have asked you to think about a specific task, learning about a specific topic, and then we do the evaluation. Some of the questions were specific, but still, if we have a look at the answers for the different scores that you gave, it's very nicely spread out. We have people who don't care much about visuals, and we have one each in the other categories. And interestingly, it looks quite similar for the other ones. It's very spread out. And so there seem to be differences in some way, but separating you guys according to those is not a good idea. Okay, so you can use these profiles if you find them fun. But that's probably about it. So let's look instead at the more established theories, the ones that turned out to be true over and over again in experiments. And I really like to structure this in two parts. The first is what motivates people to do something. And the second is what is learning itself. What does that really mean? Okay, let's talk about motivation first. It's easy to categorize motivation into two big forms. It can be extrinsic if someone else essentially motivates you to do something through certain ways of forcing you in one way or another. That can be marks or grades, so you have an incentive to perform well because you want that mark. But it's extrinsic motivation because you're not really caring about the task itself, you care about the mark. It's a difference. Rewards are a positive way of extrinsic motivation, but they're extrinsic. And punishment, well, if people are motivated by punishment or fear or pressure, definitely extrinsic motivation kind of works, but maybe not what we want. Intrinsic motivation, by contrast, is something that comes from within you. If you're interested in performing a task just because of the task, and this has a lot to do with little children playing or climbing trees or experimenting with sticks. They don't do this because we tell them to, or because they expect to be a pat on the shoulder if they assemble the sticks correctly. They just do it, and no one told them to do it. Well, they would still do it even if no one told them. So it seems that tasks are inherently enjoyable or fun in this case, or you have some ambition to reach a goal, even though there's no external pressure applied to you. And probably has a lot to do with natural curiosity as well. Now, for you as a prospective teacher or for someone who designs learning environments, extrinsic motivation is easy to achieve because that's under your control. You can set rules, you can set marking guidelines, you can give rewards. That's perfect. You can control this, and then it's there. But unfortunately, intrinsic motivation is a much stronger motivation. It keeps you going for longer. It motivates you for the actual task and not just a proxy for it. So we really would like to foster intrinsic motivation, but it's something that comes from within the children or the learners in general. So how can we do that? We can only do it indirectly. So in the rest of this section, we'll look at where intrinsic motivation comes from. And there's different theories around this, but the one that I found most useful is fairly simple. It says there's two things that play into intrinsic motivation, and you kind of need both, at least to some degree, for it to work. Otherwise, you lose the motivation. And well, if you think about it, it's not very surprising. One factor is the goal or the task that you're working on has to have some value for you. It must somehow change something for you to have achieved that, or there must be something positive coming out of it. Maybe not even just for you as one person, maybe it's good for society at large or something like this, but there must be a value that you attribute to a goal. So it's a subjective thing, and we can sometimes influence how this task is perceived. But ultimately, it's the people who learn themselves who have to assign a value to the task. And the second is a little more tricky, maybe. If you need to have a certain expectation as a learner to succeed in this task. If you feel it's either completely boring, you already know this is beyond your standard, or you can do this blindfoldedly with hands tied on the back, you lose interest. Or if you don't see any chance for you to achieve it. It has a lot to do with how computer games have to balance the difficulty. If it's too hard, then people lose interest. If it's too easy, it's not fun or not challenging. And I think this is very much the same principle applies also to learning in general and maybe to anything in life. If you don't have a reasonable expectation to succeed, you're probably not going to do it. So these two things have to be there. In the literature, people often put a plus sign between those two. So it's like the total motivation is the sum of these two. I would rather put a multiplication between them, because if either of them is close to 0, the whole motivation will be 0. I think there's no thing if a task is super valuable, but you will never ever succeed, you won't do it. And if a task has no value at all, but it's of the right difficulty, you still don't care. So I would say factors is better than summands. I linked so in the slides that I'll put on the website, this is a clickable link that you can check out. It's a nice little online course on teaching learning for higher education, but I think all of these principles apply without any changes really to any context. And there's some more well, self-paced activities where you can go through, click through some stories around it. So I found this useful, that's why I put a link there. But I want to keep it short for here in class. What does this theory mean for us? We have to make sure that both factors are okay. So if there's a barrier for any of them, we have to deal with it and do something about it. So far, so good. So let's look at this first one, the value you assign to a task. How can we make something we want to teach people, how can we make that valuable for the children, the learners? There's different ways how you can do this, and they're not always equally effective, or not equally effective for everyone, but you can try combinations of this. And if we have time at the end, I'll show you some example where we tried this last year, and you're my judges if it worked or not. But you'll probably see some of these things, at least whimsical attempts to apply it. One way to create value is to connect it to the natural environment of your learners. So either solve a real problem that they have, that they can feel in their everyday lives, or explain how something works that they're using all the time. This creates value because it's closer to your learners. You might also discuss, like, the historical context is sometimes very motivating, because then people see there's a similarity, maybe not to the task, but to the person who discovered it. So that also has to do with role models and showing the people behind certain inventions or material discoveries. And sometimes you can point out that certain things deliver something towards a good cause, help society at large in some way. It's not as direct as the other things, but many people find that more motivating if there is something to be achieved in the long run by learning this. So you could say, I don't know, programming apps can help. If you can design an app that helps people avoid garbage, then that's a goal that everyone might agree is a good thing to do. And so you make the task that you're actually teaching a step towards this goal. Humor and stories, embedding something in some cohesive story, some narrative with characters. I think this is, again, something that often computer games or other games also use, or children's books use. And you can apply this to other contexts as well. I think it works in higher education as well. It just is, well, two things. Humor is always enjoyable if it's the right kind of humor. And stories, our brains like cohesive narratives. They like if things are connected. That helps us remember it better. It helps to make it more unique and memorable. So this can be effective if it fits the topic. Another way this is slightly different. If you give your learners choices, what they're doing. Like, for example, you ask your students to pick their own essay topics, right? They might enjoy this because they can pick something that's more relevant to them. And also just the mere fact that you give control to the learners helps them feel, this is maybe also on the expectancy side of things, feel that they're more in control of the learning. It's a two-sided thing, because it can also overwhelm or cause confusion. So you have to kind of strike a balance between guiding things and giving choices. And well, creative tasks embedding in the learning is very open, but maybe you can do an arts project like the programming examples where you basically create nice pictures, artistically looking pictures through code. That can be motivating for someone who else would not be like enthused by some mathematical puzzle on an abstract level. So just create more variety of how things can be applied, and that way you can try to find something that matters for every of your kids. And yeah, it's not easy, but it's worth investing your time and thought into it because this will make a big difference. Another kind of orthogonal dimension to this is value can also come from being in a certain context. So if you're doing group work and the group matters to you, maybe the task doesn't really matter to you personally, but you want your group to succeed because some other members in the group are very enthusiastic about the topic. So you kind of play along to not let them down, even though the task itself doesn't make much sense to you. Maybe that's strong enough to keep you going. Again, group work is a delicate topic. Students traditionally are not very fond of group work for many reasons, but if used in the right way, it can be very motivating. You have to be careful that, yeah, the classroom climate remains somehow useful and helpful for everyone. I guess we all have our stories where we kind of felt as an outsider in some group, and it's not nice. It seems just part of the human nature is this in-group, out-group behavior. It's strongly ingrained in our psychology. So especially children at some age naturally fall into this pattern. And well, school teachers know how to, that this is an eternal fight. But whenever you can do something like establish rules in a class, like demand that discussions are constructive, there's no torpedo arguments that basically kill the discussion because they don't express some factual argument, but just attack the person personally. These are things you should ban, but yeah, it's definitely challenging. And depending on the age, might be really tough to put into practice. What you can do at least is be a good role model. Try to avoid any stereotypical representations. If you use examples with people, you can try to not always have the same type of people. These are all little nudges in the right direction that won't change the picture by themselves. But yeah, you can do your little share in this. The other thing is more about the expectancy. And that, again, is very subjective. If you're really able or equipped to solve a task, is probably not written in stone. And that's the idea of growth mindset as opposed to fixed mindset. I don't know if you've heard these terms before. Growth mindset is kind of the idea that if you make mistakes, that's an opportunity for you to learn, to grow. Whereas a fixed mindset would be to say, if I make a mistake, that just shows that I can't do it. And even worse, it shows everyone how stupid I am. So I won't make mistakes, or I won't admit them. I will avoid it. I'd rather not even try it, right? A very nice tag phrase for growth mindset is not yet. If you can't do something, it's always a not yet. And you can improve from there, as opposed to saying this is just beyond your skills, your reach, your talent. Talent is a very dangerous word, I think, because it sounds like something that's given, God-given, and fixed. And if you don't have the talent, tough luck, you'll never do it. And if you have the talent, you don't have to keep trying. Both ways are actually harmful. Okay, how you deal with failure, how you deal with struggling differs. And this is another one I want to mention for fixed mindset thinking. This guy, this girl has a maths brain is, again, it's kind of same as saying talented for is probably not useful to keep thinking in these terms. And what I found very reassuring is there's really no scientific evidence I'm aware of that would support this fixed mindset mentality. It doesn't seem to be true that there's like a very fixed limit that you can't get beyond. It clearly might mean that you need more time or more support, but we're not aware of very fixed barriers. And even these things like, does talent really exist, is not so clear. I'm rather inclined to believe no, unless someone can prove me wrong, because I like the consequence, because it means every fixed mindset thinking is really just within us, and we can overcome it by denying that it exists. And it seems to be closer to the truth than it might feel intuitively, or as it felt for me when I first heard about it. I think for teaching, we should essentially ban this idea that someone is inherently good or bad at something. It's always a not yet, and it's always something they can change. And a lot has to do with how you approach things. If you're constantly told, you're a girl, you can't play football, well, probably you cannot because you never try, you never practice. And the other way around, especially with gender, I'm sometimes very frustrated to observe how it's sometimes still kind of ingrained in society and even our context, that certain things are separated by gender. It drives me mad, but yeah, it's a continuous fight. We're a long way to go there. But growth mindset is a good term to keep in mind. Okay, that was the part about motivation. If you wanted to ask or tie into anything, maybe before we switch to learning, the learning part is shorter. All right, if that's not the case, then let's look at what learning means. And maybe this is something you can reflect a bit. Well, what does it really mean to learn something? If you wanted to define this, it's kind of a tricky term. And people came up with different definitions or different philosophies, and they came from different philosophical ideas that got generalized to learning. And it's basically these two. I'll go through this in some detail, but one is it's called behaviorism or instructionism, and the key idea there is that learning is something that affects your behavior. So I teach you something, and after that you can do something, and I can observe that from outside. This is completely extrinsic. It's not really talking about what happens inside you. We'll come to that. And instead, I'll teach you a skill. Afterwards, you can do this. You have this skill. You can do it. I can observe it. That's the idea of behaviorism. And it has its origins in Pavlov's dog. I don't know, you probably know this experiment. He wanted to study digestion of dogs and fed them things. And whenever he fed them something, he rang a bell. And he noticed after a while, if he just rang the bell, the dogs would start slobbering and look like they're expecting the treat, some food. And they even had physiological reactions showing that. So he kind of trained them to associate the bell with food. And that's the type of learning that behaviorism has in mind. It's externally observable. But also this origin is a bit dangerous because it sounds like training dogs is what you do when you teach children. That's hopefully not the metaphor you want to have in mind. But still, this theory is more about repetition and drill exercises, because that's how you do reinforcement learning. And for the teacher, the role of the teacher here is the central figure who controls everything. The teacher delivers the material. It's the key active role in learning who decides the structure, the content, the activities. Everything is designed by the teacher, and the learner kind of suffers through this. Is also a bit of a one-way street. And finally, a piece of vocabulary, summative assessment means something like an exam, an assessment where you do a task with learners, and the goal is to check how well they've learned. It comes after learning. You can also use assessment in a formative way, where maybe this is something like Slido questions. If I was to ask you about these concepts while you're still exploring and learning them, that can be a formative assessment where I'm not even checking who got what answer right. It's more to inform you how far you got, or if you understood some concept. Okay, but behaviorism is really about summative assessment because you want this external observability. And constructivism is kind of the opposite approach. It's all focusing on the learner, and learning means something inside your brain changes. You build structures, you build concepts by observing patterns. If you haven't heard of Piaget's experiments with children, okay, this sounds terrible, is observing children solving certain tasks. Definitely watch this video. It's hilarious to watch, and it just shows you teaching children certain concepts at a certain age is bound to fail. They haven't made the step that's necessary to understand, for example, what a number means. And no matter how often you drill them, how often you repeat a concept, they will not get it until they've made this internal step, until they've learned the concept. So this is very enlightening, but not so relevant for us at this stage. The role of the teacher in constructivism is quite different. You're really a person standing on the side, setting the stage, but then the learner has really to do everything. So the key role is for the learner. The teacher facilitates learning or sets up the environment or organizes opportunities, like this open the door thing, which show the door, but the learner has to eventually do it. So I don't know, I think we skipped this question, but I would assume that most people interested in teaching are very much on the constructivism side of things and don't really like the idea of drill exercises and telling kids every little step that they should do, and then you write the exam and you move on. It's usually not what people consider interesting or good pedagogy. I just want to again warn a little bit that constructivism in isolation or in an extreme form is usually not that helpful. The problem is that it's kind of a bias. You as one person who's interested in pedagogy, you're kind of a biased sample for what works for learners. And so you probably are interested and self-motivated in computing, at computer science at least, whereas not every child that you might teach will be. And so for you, constructivism or constructivist approaches work very well, but they might not work for everyone, because often the choice and the necessary self-motivation is a barrier. So I've experienced this with something we designed. We won't get to that part today. But yeah, so the question was, what do I have to do now? Tell me the next step. When I first saw this, I was disappointed because I thought, this is about exploring. You're just supposed to explore and enjoy and play. But for some of the kids, this was too much. They were overwhelmed by this. So you have to give some guidance. Scaffolding is a way, so you give some intermediate steps and you make the gaps shorter between that, or you tell them at least afterwards, this is what you should have seen, should have in quotes, like this is what you could have seen, this is what you can learn from this exploration activity. Another good way is to ask specific questions before you post some activity, and then use this to guide the exploration a bit. Then it's not quite as open-ended. All right. Another little vocabulary is cognitive load. This is kind of separate from the other learning theories. It's if you design things, try to keep this in mind, but it's a little hard in practice, I feel. The idea here is that you treat the working memory that learners have at their have available as a very limited thing, essentially 7 kind of chunks, similar to how many things you can memorize. Each chunk can be a complex thing in its own if that is something that you already understood, that the learner already has internalized. So it essentially just means you want to give tasks at the right size, and you want to connect it to existing knowledge, both of which is a very natural thing to do in good teaching anyways. But this is kind of the a theoretical underpinning for that. Okay, last piece of terminology is Bloom's taxonomy. Who has heard this term before? It's something that educational researchers love, and it's much more than these 3 levels. I think it's usually, okay, I don't want to embarrass myself, something like between 5 and 8. Different levels of mastery. How deep have you understood or internalized some concept? And I was very happy to see that the ACM, the US American version of PCS, or well, the Computer Scientists Association, they have a recommendation for CS curricula in higher education there. And they simplified Bloom's taxonomy to these 3 levels. So here are just the definitions. I don't really want to read this out. The idea is there's a superficial understanding where you can essentially reproduce knowledge. There's a way where you can apply it, but it's more of a skill level. And then assessment is you kind of understand the pros and cons. You can say when it's appropriate to do this. These are just different levels of how deep you can understand something. And the use for this is you want to use it in assessments to balance your questions. You can't have an exam where you only do assessment tasks. You don't want to only do familiarity, otherwise it's just bookwork. You want to have a balance of these different levels. You will probably recognize if you go through some old exams again, you will recognize that usually questions quite clearly fall into one of these 3 categories. All right. Questions about this? That's been a lot of terms. Just keep them on the back burner. And if you discuss topics in your essay that kind of feel like they touch on one of these, then follow some of the links and read a bit more about it.